Good afternoon, everyone. It is 2 o'clock. Let's start Water Wednesday. My name is Yilin Zhuang. I'm the Water Resources Regional Specialized Agent in UF IFAS Extension Central District. I'm based in Mid-Florida Research and Education Center in Apopka. So if this is the first time you tune into Water Wednesday, I just would like to let you know Water Wednesday is a water awareness program. We started to host it on Facebook along Facebook Live. And during the year, it started in 2022. And during the year, we are now hosting it on both Zoom and Facebook Live. Well, every 2 weeks, we have a water related topics. So it might be something about your gardens or something about something related to Florida Springs, Florida friendly landscaping. So we have a variety of topics all related to water, and it's a science-based, research-based webinar series. And this week, our topic is soil moisture sensor, and our guest speaker for today's talk is Gabriel Beccari. He is the Water Resources Agent in Marion County. Now let's welcome Gabriel.
Good morning, everybody. Alrighty, so I just want to, I guess I'll kind of introduce myself. Yulin already did, but thanks for being here today, and thank you, Yulin, for putting this together, for creating an atmosphere for everybody to learn. So I'm going to go ahead and close my screen back up, and we'll go ahead and get started. Alrighty, so soil moisture sensors. Pretty interesting, a little technical. We won't go too deep into the technical part today. I think the biggest takeaways for y'all will be the pros and cons of each one and where they can be applied. And but this is one of the things that I've kind of started working with recently in the last year or two, and they're really fun. A lot of cool applications and a lot of great water savings. All righty, so let's get started. So let me get my laser pointer working here. Alrighty, so objectives for us to cover today. Biggest thing is, what are they, right? And why are they important? Then we'll go into the two main types, and so how they measure water in the soil. Then we'll look at pros and cons of each, and then how we can apply these to, whatever we're doing, whether it's a garden, a large farm, or turf grass, commercial or residential. And then if we have time, I'm going to pull up an application that has a soil moisture sensor, very high tech, in a local farmer that I work with in his passion fruit field. And we'll try and look at some of the information we can collect from it and try to identify some trends and just look at this really cool technology. All right. Okay. So what are they? I think the name is, or the definition is definitely in the name, but these are essentially just sensors used to measure moisture content in soil. And they're used to dial in irrigation scheduling in your gardens, farms, or turf grass. And so these are really like digital eyes in the soil. For me, they're really helpful. I'm not the person with the massive green thumb. I can't just pick up some soil and know, oh, I need to irrigate or not. I like to have data. I like to have information. And so these are really good for that. And they come in all kinds of range and types and sizes. This one you can get at your box store for less than $10. Accuracy is questionable, but depending on what you're using it for, I have one at my house for potted plants inside, and so they're cheap and relatively effective. And then you have things like this that are connected to a solar panel, and then they have a SIM card in them, and they can send data across into the cloud, which can pop up on your phone, and then you can use that to manage your farm from your garage or wherever you're at, so they have all kinds of capabilities and all kinds of technical range. And so we're going to try and cover a little bit about all of that today. Alrighty, so one of the biggest reasons that they're important is water conservation, right? So if we can use some data to decrease the amount of water we're using, then it's a win in my book. The research shows that these sensors can reduce residential irrigation by 50%, and that's kind of a conservative number. I've seen as high as 90%. So it all depends on the application, soil type, that kind of thing. Also, farmers that are using these report cutting out irrigation events, also report a lot of savings in fertilizer too. So you could imagine if you were putting fertilizer down over a couple thousand acres and then you over irrigated or you were putting too much water down, you might wash out your soil. And so being able to dial in the amount of water you're putting down and combine that with fertilizer use, you're able to save both fertilizer and water. And so farmers report cutting a lot of costs and irrigation events, both using these things. And then also for us in residential areas, especially if we're irrigating our gardens and our turf grass with municipal water, we can lower our utility bills with these things. And the ones on the cheaper side, you can pay for a sensor with savings out of your utility bill in less than a year. Alrighty, so of the two main types, there's a smaller or different types within those. And so we're going to cover soil tension and water content. So let's start on the sensors that give us water content data. So it's essentially volumetric water content is what they call it, but it's really just a percentage of water in the soil. And so, for example, if we had a cubic foot of water and there was a certain amount of pore space in that, and 25% would represent 0.25 of that cubic foot of soil. So hopefully that made sense. And usually having 25% pore space in a cubic foot of soil is a lot. And so this would be a high percentage. But the types are capacitance, time domain reflectometry, which is, you don't have to memorize that. And then neutron probe, which I don't think anybody in this webinar is probably ever going to use, but they are pretty interesting. So I went ahead and tossed it in here just so we could check it out. Alrighty, capacitance. So this is essentially just probes that send signals from one into the soil, and then it picks it up on its way back. And it uses that electrical signal or frequency to determine how much water is in the soil, and the part of not just in the soil, but the wear and the water and the particles themselves. They all kind of transmit electricity in a different way. And so the way that signal is received correlates to water content. And so with this situation, this one's usually sent through a metal rod or rings. So here is sent through the rings, and these are different probes represent different depths. And this would be out in like a field, a farmer's field. But this one here, oops, might have froze it. One more forward. Sorry about that. This one here is also considered capacitance. And that also sends a signal from one portion of the rod to the other. But it's much less accurate. There's only like a tiny little watch battery in this thing. All right, let's get back to that slide. So these are, in terms of technology, it looks like high tech, but they're pretty reliable. And so this is why it's kind of the industry standard, but we'll see some more here. So pros and cons. The biggest and most important pro here is that they have a faster response time. So as soon as you get that signal out into the soil, it reads back in milliseconds. And so automatically, you know what your soil moisture is. These are really cool because depending on the type you can have remote access. Like I was talking about, they can talk to your phone through a SIM card or the cloud, and you'll be able to control your irrigation, not at the farm or your garden or wherever. And they're really accurate, or they need to be calibrated. And so they're accurate if they are calibrated. Some people think the calibration is kind of a con, but I don't really consider it. The calibration is really easy. You just dump a whole bunch of water on it. And then once it reaches field capacity and then the soil drains back out, you just mark your point there, and that is where you want to be irrigating at. And for anybody that doesn't know, field capacity is essentially like if you had your flower pot and you watered it all the excess water drains out into the tray underneath, but the soil's still holding on some water. That's considered field capacity. So the soil has as much water as it can hold without having excess drainage. So if you hear that some more throughout the presentation, that's what I'm talking about. It's the soil's max capacity. And so last thing is of a pro is that they're cheaper than TDR. At least the technology itself is, but we'll see further on here that TDR and TDT, which is the next slide, we'll go into more details. Those are kind of used most in residential applications. All right, cons. So small sample area, which I don't consider a bad thing. Having a small amount of data for a specific area allows you to know exactly what the moisture content is right where the probe's at. So if it sampled a bigger area, it would be, at least to me, a little more confusing on what it was representing. And then anything that's electrical, you'll see this throughout the entire presentation, will also be impacted by soil conditions like temperature and chemistry. So if you're familiar with fertilizer, it's usually an ion, and ions are electrically charged particles. And so you could see if there was an extra amount of ions in the soil, and accuracy of a moisture probe depended on how the electrical signal moved through the soil. It might impact some of those readings. Price points, so $50 for the cheaper ones, up to $350 for the kind of agricultural ones we're talking about. And then if you connected that to a data logger, it might be well over $1,000, and also including maybe a monthly plan so that you have access to that cloud data. So they can start to be expensive, but they are on the cheaper side if you're just getting like a probe for your garden. Okay, TDR and TDT. So this is a really long name for essentially just collecting, similar to the capacitance where it sends an electrical signal. Instead of out into the soil and receiving it, it sends it out to the end of this and then picks it up as it bounces back. And that is TDR, time domain reflectometry. So it reflects that signal. Or there's time domain transmissivity, which is a hard one. And that sends it along this path. And then depending on the amount of water, the speed changes. And so it uses that as a way to pick up on the amount of soil or the amount of moisture that's in that soil. So the great thing about these is internal calibration equations are pre-installed. And so that's one of the cons or the pros that we'll talk about in the next slide. They do not need to be calibrated. So they are extremely accurate. And again, no calibration required. And depending on the price, remote access is available. And it will, actually, this is supposed to be over here in pros. There are options for data loggers. And so you can have that thing collect data over time. For some of us that are just getting water in our gardens, that doesn't matter. But other folks really like to have recorded information on how long they're irrigating for. I like to use it because I compare it to my water bill every month, and I can see, oh, my garden, cost me a little more this month. So for nerds like me, data logger options are pretty cool, but definitely unnecessary if you're just trying to determine how much soil moisture you have. Again, a con here is small sensing area. They can be a little expensive. On the low end, you can get $150 ones that are connected to your irrigation in your garage that controls your turf, or they can be up to $3,500, and they can be doing all kinds of crazy things, connecting to hydroponic greenhouses and controlling all the irrigation. So again, a huge range on price here. Okay, neutron probe. So this is really high tech, but I thought it was really interesting. I thought people would really like to see this. So essentially, this is just a gauge that reads the amount of neutrons in the soil. And what it does is drop radioactive material in here. And I know radioactive sounds scary, but it's really just an element that has a high mass. And so it puts out neutrons from that element into the soil, and it reaches equilibrium. And then there's a gauge in there that can measure that equilibrium and equate that to moisture content. So these are considered the most accurate. They also read over a large distance, like 30 to 60 feet. They are very expensive, right? $10,000 a unit. That's kind of why I said we probably wouldn't see anyone in this presentation using them. And they also take a long time to collect readings. You need to be licensed. And again, I said that contains that radioactive material. So that's probably why you need a license, right? You need to be able to handle this stuff correctly. And also, well, not also, it's just typically because of the price and the accuracy, it's not really practical for anything other than research. And so you often see these in research situations. All righty. So soil tension probes. So these are a little more of the low tech. And this is the type of probe that I started with. I worked at an orange grove and a row cropper while I was in college. And he had a few of these near some of his trees. And also he had them in his plastic mulch situation. And so we would use these just to make sure we weren't over irrigating. And also you can use them to dial in your schedule. So you can put them at different depths, and depending on how much water you put down, you can see if it's going to react at 1 foot, 2 foot, 3 feet or more. So they're pretty useful. And since they're low tech, they're a little more reliable. But essentially soil tension is just the amount of energy a plant needs to extract that water from the soil. So if there's more water in the soil, there will be less tension. So it's easier for the roots to extract that water. It's usually reported in some kind of atmospheric unit because they're under a vacuum. And I'll explain that more in the next one. And then measurements are very unique to the soil type. And so these also need to be calibrated based off of where you're placing them. And so one of the best techniques is kind of stick it in the soil. And then once you see some plant stress, then you'll mark that and say, okay, I want to irrigate before that point. And so they're kind of like a relative reading. And there's two types of these. There's a tensiometer that uses no electricity. It's just a vacuum reading. And then there's also one that's kind of a blend of tensiometer and then the probes that we talked about earlier that use electrical signal. So a tensiometer, this one, these are kind of like the industry standard, or were before all these other technology or all these other probes came out. There's a vacuum gauge on here and then a ceramic tip, and that is porous. And so once this is down in the soil, it interacts with the water. And so if the water easily moves into this porous tip here, the vacuum is considered low. And then as it starts to get drier in there, down in the soil, there's less interaction here with that water. And so the vacuum gauge says, okay, we have more tension in the soil. It's harder for the water to interact with this porous probe. And so the roots are going to also have a difficulty pulling the water out. And so that represents, the soil tension represents how much moisture is in there. And so if you're looking at the gauge here, you can see that 0 on the reading or 0 on the gauge would mean it's wet. So there's plenty of water here. There's almost no soil tension. And then as you move into field capacity, remember we talked about that earlier, that's right where you want to be. So within that range, there's plenty of soil or plenty of water for the plant roots, but you're starting to see it move from saturated to starting to dry out. And then through the rest of this gauge, you can see, depending on your soil type, where you might want to start irrigating. So as you move from field capacity to, and you're in a sandy soil, to this range, you might want to think about irrigating. And then if you're in a silty soil or clay soils, you can definitely let that vacuum increase a little bit because they tend to hold a little more water for the plant roots. So we always had dry erase markers, and we would just put a mark on here where we wanted to make sure we irrigated. And then if we were out on the four-wheeler checking things out and we saw that we needed to irrigate, we'd call and say, hey, go ahead and turn the pump on. We got low readings over here. So tensiometers are really cool and really low tech, other than the ceramic tip and the vacuum gauge. They're pretty cheap. All right, so pros and cons of these things. Inexpensive, I think, is the biggest thing. Between $50 and $100, or $50 and $200, you can get a couple probes and the maintenance kit, which is pretty much like a reverse bicycle pump. You use it to put the put the tensiometer under a vacuum, and that allows it to have that porous interaction with the water that's down in the soil. They're great for Florida sands. So we have a lot of coarse sands here in Florida. And so that interaction with the soil, the water, and the coarse sand is really reflected in tensiometers. They come in various lengths. We often had two in the same location. We'd have, I can't get my slides to bounce back here. We would have a short guy like this near the surface, and then we'd have a longer one farther down, like towards the last third of the root zone. And so if we irrigated and the top one showed a response and the bottom one didn't, we would know we needed to add a little more water to reach the bottom of that root zone. And so that's a great thing about having them being cheap and various lengths. You can install them in different places. They're also pretty low tech. I think I mentioned that. And then you can make your own. So if you're curious about doing that, you want to save yourself some costs and you're handy, reach out to Yelin and I, and I'll share a document that shows you how to make your own. The most expensive part is the vacuum gauge and the porous tip. It's a special order piece. The rest of it is just PVC and materials you can get at a local box store. The cons of these is that porous tip is going to respond a little slower compared to something that's just going to send out an electrical signal and pick it up in a second, or actually milliseconds. So they do have a slower response time. So as I mentioned, we would mark them with dry erase markers. We would actually mark it a little before. And so we knew we're getting to that area where the plant's going to start to stress. But really what that means is in 20 minutes or an hour, we're actually going to see some plant stress. So let's go ahead and irrigate now. They are not very good for fine soils. So that interaction of the porous tip and the fine soils can kind of mess up how much the vacuum readings get picked up. So they're definitely best used in coarse sands. But here in Florida, 90% of that is coarse sands. So if you were doing it, if you had potting soil or you brought in some soil for your raised beds, you might want to dial it in and tinker with it a little bit just to make sure you're getting accurate readings. They do require maintenance. So let me go back a slide here. This is an empty one. They're usually filled up with the fluid, and then you pump it and then you put it on a vacuum. And so you can have that interaction. And like I said, the vacuum is like the reverse bicycle pump. You just pump it backwards, and it puts a little vacuum on all the material in here, and that allows it to have that interaction with the soil. So with that, the liquid that's in there can grow algae unless you add some kind of a biocide. And that comes with that maintenance kit that I was talking about. You know, you get a probe and a maintenance kit. It comes with a biocide that you can add in there. And so if you realize you had a leak, you can rinse it out, clean it out, add that biocide, and put it back under a vacuum, and you'll have readings in a few minutes. Well, maybe a little longer than a few minutes, but before the end of the day. These also cannot freeze. So here in Florida, that's not too much of a worry, but we do have freezes. So make sure if you have some out in your garden, you want to get them up before we have a hard freeze. They are full of liquid. And then they also don't have any, there's no data logging, and you can't access this data from your phone. So you have to drive out, like I said, on a four-wheeler or walk out to your garden and collect your manual readings. Alrighty, so this is the electrical resistance type, or granular matrix. So this is a blend of both. They have the porous tip here, but an electrical signal goes from one side of the probe to the other through this porous material. And this porous material forms an equilibrium with the moisture in the soil. And so it's representative of how much moisture is down there. So this absorbent material is often gypsum, which is the same stuff that our walls are made of, drywall. And so it's absorbent of moisture, and but it doesn't overabsorb. It's not like a sponge. It just reaches equilibrium with what's around it. And then an electrical signal is sent through there. And so, like I said, it's a blend of tension and electrical resistance. So these need to be calibrated, but always soil moisture calibration is very easy. You pretty much put water on it, and as soon as it reaches field capacity, you mark that in the instrument. So very, very simple. And they're installed passively. So these can go in the ground, and you don't need any electricity connected until you go and get a reading and you use one of these guys. You plug the end of this into that and then hit read, and it will give you your electrical conductivity or your resistance reading. And all of that equates to a certain amount of soil moisture. And that's really easy. Once you purchase the equipment, it has kind of a guide on how to determine that. And then the unit itself is battery powered, but again, they don't have to have batteries out there. You just need to keep that with the handheld reader that you have. They can also be wired to your sprinkler system, and we'll look at that later when we start to talk about the applications of soil moisture sensors. Alrighty, so let's look at pros and cons of these guys. So pros are they do really well in medium to fine soils. And so if you're in an area that has less sand and more material that's finer, you can install it there and they'll be relatively accurate. But they do still do well in coarse sands. They're just not as accurate. You just got to like pay attention a little more to them. They are cheap, relatively, $50 per sensor is not bad until you start to add sensors, right? That can add up pretty quick. And then the meter itself is about $250. And so, it's like I said, it's relatively cheap, definitely doable for a farmer, maybe a committed gardener, right? But that's still a little expensive. It can be logged and retrieved remotely, but that's going to add to costs. There's definitely units out there that can connect to your Wi-Fi or through your phone through Bluetooth. Those are usually connected to greenhouses, but they're pretty useful. And then if you leave them connected, they can provide continuous measurement. So you can collect data over time as identify trends and things like that. And that's really useful for commercial growers, especially in greenhouses. They can track water movement and different soil blends and things like that. The cons are similar to anything that, like the tensiometers, anything that has to form equilibrium in the soil. It's not going to send that electrical signal, so it's going to take a little longer to take that reading. They are less accurate in coarse sand, like I said, but it's not completely, don't give up on them if you do have coarse sand. They are sensitive to soil conditions, anything electrical, we kind of went over that. Added nutrients, added ions will kind of adjust the way it reads. And then they also need that calibration per soil type. But I say that everyone, I think anytime you put down a soil moisture sensor, you should keep an eye on it based off of where you're at, and it's kind of like a trial and error until you get it dialed in. Alrighty, so applications here. So you can see in residential or commercial turf, there's a really great options, and there's really great use for these in terms of water savings. And so you can see both tension type used here. Hunter has one, Hunter sprinkler systems. They have one that connects to your irrigation controller. And then this is the same. This one, I can't remember who makes this one, but it is the TDT, or no, the TDR. This is no, it's TDT, transmissivity. Yep. So it sends a signal along this thing. Either way, they're both buried about 3 to 6 inches under your turf grass, and then it will communicate with your controller. And one of two ways: it can either bypass an irrigation schedule, so you can pre-program your irrigation schedule in, and then it will send a reading to that thing and say, hey, whoa, we got plenty of water down here, don't irrigate. So it will just bypass something you have pre-scheduled. But then the new technology, there's a couple more. There's another, if you have one, there's going to be another knob here that you use to set your range. And it's really new, like in the last few years. But what they do is they control your sensor based off of the soil, the sensors that's in there, or the moisture content. So as it starts to decrease, it will kick your system on. And then as it starts to increase, it'll shut the system back off. It takes a little more calibration and it's a little more work. You also have to program it to meet the standards of your irrigation restrictions for your local area. So you don't want that thing in the middle of the day, you're out having a picnic and it's just kicks on, right, and sprays everybody down. And so the new technology still is kind of getting dialed in. You can definitely program times that it works and doesn't work, but the bypass is by far the most common right now. Installation for these things. So a single sensor can be used for multiple zones. But if you want to really dial it in, you can put a sensor per zone and they can be wired in just like the valves that you use to turn on different zones. They can be wired to control each valve. And so that's a really great way to dial in some of that irrigation and some of the drier areas or wetter areas in the lawn. But if you're only going to use one sensor, you want to put it in the driest zone. And that's because if the dry zone is irrigated to where it needs to be, then you can guarantee the rest of your yard is going to be healthy. The only problem with that is if you have water that builds up in one area or another, you want to be careful. You don't want to encourage mold and fungus. And so an irrigation technician will really help you out with that. You can also call your local extension office. And also one last tip, when you're installing it, put it in a low traffic area. You don't want to stick it right in the yard where you walk over every time you get home from work. So you're going to end up compacting the area around the probe and it won't get the data readings or the readings that as accurately as it could. And then also put it away from a sprinkler head. So if it's near a sprinkler head, it'll get wet sooner and tell the system to kick off prematurely. Alrighty, so applications in the garden. So this is a tensiometer in a potato plant. You can see it's a little hard to tell, but it's got the moisture it needs. It's about ready. It looks like it's in field capacity and could use some water in a little bit. But these are really great. It's put right in the root zone of the plant and you're able to determine if it needs anything without having to dig it or put your finger in the soil or anything like that. So that's the tensiometers. I think that's the cheapest and most practical. But there's also different options. So compost moisture meters are also used in gardens frequently. These are between 50 and $100. And they actually they are electrical resistance, but they don't give you a percentage. It's just a meter that's between 1 and 10. But the good thing about these is you can calibrate them. So again, you irrigate to field capacity and then stick it in the soil. And then you can use a screwdriver and a knob that's on the unit to put the dial in at about 5 or 7. And then that way, when you come back with that probe in that same soil type, you can stick it in there and you say, oh, okay, I'm at 4, I need to irrigate, or I'm at 8, I got plenty of water. And so the good thing is with these, or thing to remember, is that you want to research the root depth of the plant you're trying to make sure. So all plants kind of have a different root structure. Some are shallow and spreading. Some are deep and penetrating. Oops, hit the keyboard on accident. And so just make sure you know that. And depending on where you're at, put a mark on your probe so you know that you're putting it in the same depth every time. And then the last would be hand meters like this. It was hard for me to find a picture for the hand meter. I was actually trying to show you. There's a lot of copyright laws and things like that, but this one is very similar technology. They use it for curing hay and checking the moisture inside of those. These are common in greenhouses, but they will give you not just moisture content on a digital readout, but also electrical conductivity. And that is a very roundabout way of determining how much nutrients are in your soil. And so some of these probes, they're between $100 and $300. You can use to determine not just your moisture, but your fertilizer. And again, if you get one of those or you want to look into that, you can talk to your local extension office and they'll help you out. And also, I just added new technology here as a quick bullet. If you go on, everybody's favorite online mail order website and type in soil moisture sensors, all of these different types come up. Some are TDT, some are electrical resistance, all different price ranges. I'm not super comfortable telling you which one is going to work better than the other because I don't have as much experience. But if you're ready to mess around with it, go ahead and order yourself one and figure out how it works and get back to us and let us know. But there are a lot of cool and interesting new technologies out for soil moisture sensors in the home garden or in the turf. Oh, I think, did it freeze? Oh, we're good. We're good. All righty. And then so one of the last applications is agriculture. I think I've talked about it a lot already. So here's a probe here, and they have multiple sensors down the probe, so you can read in multiple depths. And then this has a rain gauge on it, so you can correlate the amount of rain with an irrigation event or the amount of moisture in the soil. And then all this information can get sent to your phone with the SIM card installed in this, and it allows you to monitor your farm across from a distance, which is really great. When they put these in there, they make sure they're in the root zone of the plant, but not directly under an irrigation emitter. So that would really give you false readings on how much water is actually in there. And you want to make sure you put it almost to the end of the root zone, but away from an emitter so that you can guarantee that the roots are getting the water they need. Usually they have multiple sensors, as I said before, and you want to place this in a representative area in your field. So not like turf grass where you'd want to put it in your drier area. If you could think about this on a huge scale where you had over 500, 600 acres, if you put it in the driest spot, you might end up over irrigating a big portion of your field. And so you want to put it in a place that represents what most of your field is like, so that you get the right irrigation to 70% instead of over irrigating 70% and then irrigating the 10% that's dry to the perfect amount, if that makes sense. And so you just want to find a place that represents what most of your field looks like. And then sensor or probe per soil type. Oh, gotcha. And so you also, different places in your field, as you cover a big distance, you can have different areas in your field that some may be coarse sand, some may have you might have a clay lens somewhere, or maybe it was a wetland that drained out and there's a lot of humic area. So if you can afford it, you want to get a probe in each one of those different areas so that you can dial in the irrigation based off of soil type. So definitely can add some costs, but definitely pay back whatever you spend on them, on water use, fertilizer use. A lot of pumps are run by gas and diesel, and so it can save that as well. So pretty great applications, and sensors can be used in all kinds of different ways. One last thing before we look at a sensor that I have installed is that these here can also be used in a garden or a small farm. So you could install one of these sensors in your row crops, or say you had a small garden plot, and then connect that to an irrigation controller that's traditionally used for residential or turf, and use that to irrigate your garden. So you got to be a little handy and you got to tinker a little bit, but it's definitely an application for using that. And I know a few guys that are doing that, and they have had great results so far. So just something to think about. Alrighty, and so last we're going to check out Field Climate, which is one of the soil moisture sensor applications online. And we're going to look at just different things we can see through it in real time and try to identify some trends that it represents. But before we do that, I just wanted to give you a quick rundown on what we'd be looking at when we look at those. So this is, I tried to correlate one of the graphs to each one of the probes. So here's the surface probe at 4 inches, and you can see some moisture and then an irrigation event. and then you see it drain out, and then the excess water drains out, and it starts to, you can see the plants actually drinking it. So this is field capacity is reached right around here, and then the plant's actually using some of that water, and then another irrigation event. So that's at 4 inches. You see it again here at 8 inches, and then less so at like 16 inches here. You see that irrigation event, but the plant roots don't seem to go that deep. You see a little bit of a bump. So you can see here, this farmer's doing a great job on irrigating just down to 16 inches, which is probably the max of that crop in particular, and keeping his soil moist while conserving what he needs to. So I'm going to stop sharing. At least I'm just going to cancel this and the slideshow. And then we're going to go over to this guy here, log in really quick. If I remember my password. All righty, so this is what you might see. Let me get this out of the way. In real time. And it's very, very cool. So live data, this one's hourly for the last 30 days. So like I said, in that one, the one we showed on one of the last slides had a rain gauge in it. So here you can see rainfall. We had 4 inches in the last 30 days. So that's precipitation. And then you can see the spikes, right? And then all this is gridded to the same. So you can see this spike represents this here. Then we have some irrigation events all in between. Then we have another spike, some more irrigation events. So it's really interesting. You can correlate not just irrigation events, but also local precipitation, and combine that with local weather data. You can really start to see some of the information here. Then you also see here volumetric ion content and soil salinity. And so what that actually is the kind of a roundabout representation of nutrients. So if you look here, we have kind of consistent, and then you see at the surface, what is this? Content 1, which also means probe 1, this kind of light pink line here. And then you see it start to spike, and probe 1 is at the surface. And so what might have happened here, I talked to the grower and it did, this is about where they fertilized. And so you can see a spike in fertilizer here. And then you also see, remember when I mentioned that soil salinity and water and temperature can adjust the accuracy of your readings. If we go back up here, we see a really big irrigation event, right? Or precipitation event. So you see a big spike in soil moisture content, but added water also increased our soil moisture, or our volumetric ion content. So you can see how that interaction of salinity and everything else can kind of, or salinity, temperature, and water can adjust your readings a little bit. So it's really important, and kind of one of the difficulties right now of all this data is interpreting what you're reading and what you're seeing. And so this is something I just thought y'all would like to look at. And then last thing I'll show you here, we're going to zoom in on just this time period here. And then we'll look at each probe individually. So this is soil moisture at the surface. So you can see irrigation event, and then field capacity, another small irrigation event. Now let's turn on soil moisture probe 2. That one's 4, I think, inches lower than the other one. And you can see here, it kind of follows it, but then you have less moisture here compared to here, right? So this is closer to the surface. Now, where it can get confusing is we add these two down here. You'd think that they would be in order. So you have probe 1, probe 2, probe 4, and probe 3. And then add these last two, 5 and 6, and they're falling in the middle. And so you think your moisture content might be correlated from top to bottom, as the most moisture is at the top and the most and least at the bottom. But here we're seeing probe 1, probe 2, probe 5, and 6 all holding more moisture. and then a section of the soil here, probe 3 and 4, not holding as much. And so this is how some of these complex readings can start to confuse people, right? And what we think is going on here is that this soil here is more dense and it doesn't hold as much moisture. But the challenge here is if you were to purchase one of these probes and put it in the ground, and then you start to get crazy readings like this, what do you do? How do you interpret this? And so that's kind of the challenge that everybody deals with this high technology and all this excess data that comes in. You got to be skilled, not just in farming now, but also interpreting all this data. And so while it comes with a lot of really cool benefits, there can also be some challenges. All righty, and so that's it for me. I want to, I guess, stop sharing here. And then I guess I'm ready to take any questions.
Thank you, Gabriel. That's very informative. That's great. Thank you very much. I did post a question in the chat box. I do want to know what everyone, just what's your first impression when Gabriel showed you all the line graphs? Because he mentioned that it's the challenge, but since you sat through the whole webinar, he walked you through the process. We are really interested, just curious to know what you think of that. I will give some of you some time just to type in, and also let you know I put some additional links in the chat box. I have some extension fact sheets related to soil moisture sensors. Yeah, so earlier I asked that question. It's what's the first impression when you saw all the graphs? That's based on our conversations with these adopters, like these people who have soil moisture sensors. They have these fancy soil moisture sensors with data log and online access, just like the graph Gabriel showed you earlier. It looks, to me, it's like, I love it. I love all the numbers. I love the data. I dive into it. I export it to Excel sheet. I make my own graph, but that's just totally me. Most of the people I have talked to, they just like, once they see all the lines, that basically that's it. Also, just like, because it's just so complicated. There's just so many information there. Not sure like which line I should look at, and also what it really means. Yeah, so how about you, Gabriel? How about your growers? Have they provided that kind of feedback to you?
I've had a blend. So I've had some that are like us, that really love trends and technology. And so he really got into it. He's texting me after hours like, hey, did you see that rain event? It got all the way down to this depth. And I've had others say they just want someone to read it for them and tell them when to turn their irrigation on or off. And so, it's kind of the whole range. And, the tension meters, the tensiometers that we used at the Orange Grove, everybody seemed to really like. They were pretty simple to read. And whoever was out in the farm, it was really easy with that marker on the vacuum gauge to just say, hey, it's time to irrigate. So those are cool. And then for the home gardener who doesn't want to deal with any of that, the compost moisture sensors are really great because you can just calibrate them to your soil, and you kind of get a representative moisture level. It's not actually percentage or anything like that, but it's good for being practical at least.
Yeah, that's great. And thank you for providing a wide range of soil moisture sensing technology. It's great. I've been checking our Facebook and the chat box. So I guess they are a little bit stunned by your graphs at the end.
Yeah, maybe too much information.
It's all great. Thank you so much, everyone, for joining us for this webinar. And thank you very much, Gabriel, for this informative talk. If you have any questions related to soil moisture sensors, you can send us an email, or if you are watching it on Facebook, just leave a comment. We'll get an answer back to you. And thank you again, and hope you all have a wonderful Wednesday afternoon.
Thank you.
Bye.